Chapter 10 is all about geometry, and section 10.1 is points, lines, planes, and angles. A lot of definitions and some problems. A point has no length, width, or thickness. It's just this right here. It's just a dot. And we label it with a capital A, and we call this point A. A plane, jumping down here, is a flat surface that has no thickness and no boundaries, and we generally show a plane like a parallelogram. That's a plane. It extends in two different directions. A line connects 2 points by the shortest possible path. It has no thickness and extends indefinitely in both directions. And a line can be named by using two of its points. This is line AB, in which you would see symbolically, you'll see AB, and you'll see arrows on both ends. That means it continues all the way this way, continues this way. Line AB is the same as line BA. It's very important that you pay attention to the tops of these, because you're going to see in a minute the difference between line, half a line, ray, etc. is related to what these symbols are. So a point divides a line into three parts. A point divides a line into three parts. The point and two half lines. So here's my line, and here's my point, and it divides it into three parts. The point, and this half line, and that half line. A ray is a half line with its end point included. So there's a tiny little difference between half line AB and ray AB, and you might not be able to see it very clearly on this, but the half line, this is an open circle because the half line does not include that end point. Ray AB, this is colored in, and this looks just like that. Ray AB, blow it up a little bit, is this. But half line AB still has an arrow at this end, but it has an open circle. So when you're doing your homework, you might have to hit the little magnifying glass to blow the picture up to see what the symbols are. And then a line segment is a portion of a line joining 2 points and including the endpoints. So it is AB or BA. An angle is formed by two rays and a common endpoint. So here's the two rays. There's one ray, there's the other ray, there's the common endpoint. This is ray BC. This one down here is ray BA. So those are our two rays, and the common endpoint is that B. And the sides of the angle are rays. We can name this angle several different ways. You can call it angle 1, you can call it angle B, or you can do it with the three letters. You can call it A, B, C, or C, B, A. You have to be careful about the one letter. If there were two angles at B, let's say this was my picture, and I had A, C, D, and this is B, I can't call this angle B. If I'm talking about this angle right here, I'm going to have to call it ABC or CBA. One other comment about these symbols, notice this is what this book uses for angle. I generally just use this without the little curve in it. It's the same thing. There are common types of angles you might be familiar with. If the angle measures less than 90 degrees, it's acute angle. So if it's less than 90, it's little and it's acute. That might be a way to remember it. A right angle measures 90 degrees. The right angle is indicated by the little box in the corner. An obtuse angle measures more than 90 but less than 180. And you can think about obtuse kind of like the word obese. So that's big angle. And a straight angle measures exactly 180. Two other words, complementary angles are two angles that add up to 90. Two angles that add up to 90. So a 30-degree angle and a 60-degree angle would be complementary because their sum is 90. Supplementary angles are two angles that add up to 180. So if we had one angle was 100 and the other angle was 80, then we've got supplementary angles. Now picture-wise, complementary, one way to look at that is you will have a right angle drawn and a line through here somewhere, and let's say they tell you this is 20. Because of the right angle, this angle and this angle are complementary, so subtract 20 from 90 gives us the 70. Same idea here with the picture. It's going to look like this. We would have a straight line with an angle jutting out. So let's say this is 40. Then to find this, 40 from 180 is 140 degrees. Notice that adds up to 180. Notice that adds up to 90. So you will need to memorize this or put it on your card. One easy little thing in case you tend to get these kind of words confused. C comes before S in the alphabet. 90 comes before 180. Vertical angles have nothing to do with a vertical line. Vertical angles are angles that are formed when two lines intersect. Anytime you draw two intersecting lines, you are creating vertical angles. And actually what you are creating are pairs of vertical angles. This and this, it makes one pair of vertical angles. This and this makes another pair of vertical angles. And vertical angles are always equal to each other. What I mean by that is the two reds are equal to each other and the two blues are equal to each other. I am not saying the red is equal to the blue. It's the ones that are opposite each other. Parallel lines make angle pairs when you cut the parallel lines by a transversal. What a transversal means is a line that cuts across these two parallel lines. We have created three special types of angles. One type is called alternate interior angles. Now, these words are not crucial. You're going to be able to do the problems without memorizing the words, but I will show you what they mean. Alternate interior. Interior means angles that are on the inside of these lines. So there's only, these angles are interior, 3, 4, 5, 6 are interior. And the ones that are alternate interior are the ones opposite each other. So angle 3 and angle 6, that's what the alternate means, and angle 4 and angle 5. That's your alternate interior. Your alternate exterior, I can keep these same lines right here. The alternate exteriors are talking about these angles up here that are exterior, they're outside of the parallel lines. And we can also have alternate ones. 1, 2, 7, and 8 are my exterior angles, and the ones that alternate are the ones that go opposite. They alternate across the transversal. So angle 1 and angle 8, and the other pair is angle 2 and angle 7. And corresponding angles are angles that are on the same side of the transversal, and one is interior and one is exterior. And the best way I can show you corresponding is this idea. I made a little sketch of this. If I place this right on here, if I were able to just chop this off right there and pick this up, you see how that slides right on top? That's the idea on corresponding angles. This lower quartet, 5, 6, 7, 8, will land up here on 1, 2, 3, 4. And it lands not randomly, it lands specifically so that 6 goes up to 2, 5 goes up to 1, 7 goes to 3, and 8 goes to 4. Now what's that got to do with the definition? It says they are on the same side of the transversal, and one is interior and one is exterior. Okay, here's 2. If we're talking about being on the same side of the transversal, my only options are 4, 6, and 8. 1 is exterior. This is an exterior one. Which one is the interior down here? 6. So angle 2 and angle 6 are corresponding angles. But I really think physically, this whole idea of thinking about sliding this up. So who goes up here? 6 goes all the way up to 2. 5 goes all the way up to 1. 7 goes up to 3. And angle 8 goes up to angle 4. Something important about alternate interior angles. The alternate interior angles are congruent to each other. So angle 3 and angle 6 are equal. Angle 4 and angle 5 are equal. So 3 is equal to 6, 4 is equal to 5. Alternate exterior angles are equal. Angle 1 is equal to angle 8, angle 2 is equal to angle 7, and all of your pairs of corresponding angles are equal. Now that might seem confusing to try to remember all of that, but a very easy way to get the equality of angles under control is just this. I think about starting at the 1 and making a little snake, a little curvy thing through here. Angle 1 equals angle 4, which equals angle 5, which equals angle 8. So if you knew that angle 1 was 100 degrees, that means angle 4 is 100 degrees, angle 5 is 100 degrees, and angle 8 is 100 degrees. Without remembering the names of these, the snake tells you what happens. I can snake the opposite way, 2 to 3 to 6 to 7. So angle 2 equals angle 3 equals angle 6 equals angle 7. Doesn't matter if you remember the labels on these, just remember that snaking. And if you know this information, if you knew that that was 100 degrees, you should know what angle 2 is. We had it a couple screens ago that these two next to each other making a straight line add up to 180. So if this is 100, his next door neighbor is 80. And every angle along my blue snake here is 80. All of these measure 80 degrees, just like all of these measured 100 degrees. So I hope that makes all of this parallel lines and angle pairs a little bit easier for you so that you don't actually have to memorize the names of the angles. The important thing is which ones are equal to each other. Also, if you know an alternate interior angle pair or an alternate exterior angle pair, or a pair of corresponding angles have the same measure, then you may conclude that the lines are parallel. Go back a second. We were able to do this arithmetic because we knew the lines were parallel. Having parallel lines creates all of these equality situations. It works the other way around. If you know you have a pair of alternate interior angles that are equal, then you know that the lines are parallel. So let's say this is 40 degrees and this is 40 degrees. Those are alternate interior angles. Therefore, the lines are parallel. Even if you don't recall that they are alternate interiors, think about the snake through there. Snake right through here. Right through here. And if along the snake you have equal angles, then you have parallel lines. That would be a picture of the alternate interiors. Let's say this is 110 and this is 110. These guys are alternate exteriors. Even if you don't know the name, follow the snake. Boom. Those are equal. That means the lines are parallel. And let's say this is 110 also, and this one's 110. We can follow the snake. Those are equal, which makes the lines parallel. And those are corresponding angles, not that you really need to memorize the word.